Okay, good morning to everyone. So all of you can able to hear my voice?
Yes, sir.
Okay. Okay, in the last class we have seen, okay, how we construct, okay, last class we have seen how we construct larger decoder, larger decoder from smaller decoder. So we have seen that. So in this concept, anybody has any queries regarding this? How to construct larger decoder using smaller decoder? Anybody has any queries regarding this? It's because it's a very important topic. If you consider any gate question regarding in the topic of decoder, very often they will ask you like that question. Okay, you want to construct like the decoder using uh, 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 okay, like that they will ask you. Okay, do you have any queries? The construction of larger decoder from smaller decoder? Hello? No.
No, sir.
No, sir.
Okay. And today, what I'm going to do, uh, today, if you consider any, for example, inside the motherboard, what happened, processor are available. Okay, inside the motherboard, what happened, the processor are available. So, what are the components are available in the processor means? Maybe it's containing uh, adder circuit, adder circuit, and then followed by it containing n number of decoder and encoder are available. Okay. Uh, okay, I will tell you now what I'm going to do. I'm going to implement full adder function using 3 by 8 decoder. Let's see how to implement that. So okay. So now what I'm going to do. So implement of full adder, implementation of full adder using 3 by 8 decoder. Okay. So what do you understand from this? Um, okay. So you want to implement the full ladder. Okay, what is the meaning of full ladder? Full ladder means it's going to take input as a 3 bits and then it's going to perform sum. So while performing sum, what happens? It's going to generate two components. One is called as a sum, another one is called as a carry. This is a carry. This is nothing but sum. Okay, this is the first input. The first input may be carry. Okay, the first input is nothing but carry in, carry in. This is the first input. This is the second input. So based on that, what happened? It's going to perform addition. So now, what is the objective is I'm going to implement 3 by 8 decoder that functionality of full adder. Okay, first of all, suppose like that question is given. So how we are going to solve means the first step is okay, write the truth table. If they like that question they given what happened, maybe some cases what happened, you want to implement half adder circuit using 2 by 4 decoder. Maybe they will ask you that cases how do you do that. The first step is write the truth table. So whatever the concept they given, first of all what happened, you should write the truth table. The second step is obtain the boolean function, obtain the boolean function in sum of product format. Sum of product format. So what is the meaning is consider the truth table. You consider the first output line. The what are the places output equal to 1? You take the respective min terms. That is called as a sum of product. That is called as a sum of product. The third step is implement the decoder using OR gate. Implement implement decoder, decoder, implement using decoder along with the OR gate. Suppose your input is active high. Suppose my input is active low in the sense we are going to implement that circuit using NAND gate. Okay. So let's begin one by one. So what is the first step? You should draw that truth table. Am I correct? So full adder. So obviously full adder is going to take a 3-bit as a input. So what are the output? It's going to generate the output as a two component. One is called as a sum, another one is called as a carry. Okay. So 3-bit means how many number of combinations are available? 8 input combinations are available. Okay, write it by one. 0 0 0 0 1 1 1 1. Okay, so what is the output? Already we discussed that. What is the output? 0 0 1 0 1 0 0 1, and then 1 0 0 1 0 1. The next is 1 1. Okay, the first step is over. What is the second step? The second step is nothing but you want to form sum of product. You want to form the Boolean equation using in the form of sum of product form. Okay. So here two outputs are there. One is called as a sum, another one is called as another one is called as a carry. So you want to form Boolean expression for each output. So first I consider sum. First I'm going to consider sum. Okay, you look at the output. What are the places output equal to one? Here one, here one, here one, here one. You take the respective input value. So that is called as a sum of product. Okay, I'm going to take the respective input value. Okay, what's the input value? 0, 1, 2, 3, 4, 5, 6, 7. Okay, you can write it as in two ways. You can write it as in the form of sum of product. Otherwise, you can write it as the respective decimal representation. Okay, 1, 2, 4, and then 7. Here, 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 here. Okay, this is for sum. So next, similarly, same operation you are going to do for carry. Okay, consider the output. What are the places output equal to one? Here, 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 here. Okay, so I'm going to take this one and this one and this one and this one. So what about carry? The carry is nothing but 3, 5, 6, 7. Okay, this is carry. Okay, and then you should draw the respective uh, diagram. Okay, how do you draw that? Okay, uh, um, okay. For example, if you consider the sum, so the output range, if you consider the sum equation, so what are the decimal values are up here? 1, 2, 4, 7. So what do you understand from this in the sense? It's going to generate the output from 0 to 7. So that is nothing but it may be generate 8 output. That is a meaning. That is a meaning. Similarly, you consider the carry. So what are the outputs are available? 3, 5, 6, 7. So maximum value is 7. So what do you understand from this? Maybe the carry is generate. Maybe the carry is generate. The output range from 0 to 7. That is the meaning. What is the meaning is it may be generate 8 output. Okay. How do you implement that? Okay. Already they given in the question. You want to implement the full adder circuit using 3 by 8. So already you know that. What is the meaning of 3 by 8? It's going to take input as a 3 bits and then output as 8 values. That is the meaning. Okay. You follow that procedure. Okay. So now what I'm going to do? So now what I'm going to do? First I'm going to implement the sum, and then next we go for the carry. Okay, first what happen? I'm going to take one decoder, 3 by 8 decoder. Okay. So what are the output it's going to generate? So output is 1, 2, 3, 4, 5, 6, 8, 7. Okay, this is decoder. Okay, similarly you take another decoder. So this is for sum. Okay. So what are the variable you take as input? X, Y, Z. So X, Y, Z, X, Y, Z. Okay. And then what is the output? 2 is 1 and 4 is 1 and 2 is 1, 4 is 1, 1 is 1 and then 7 is 1. Okay, these are the output. Okay. So what is the meaning is, okay, uh, 1 plus 2 plus 4 plus 7. Okay, what is the meaning is, for example, what is the representation of 1? 1 is 0, 0, 1. So 0, 0, 1 means how we are going to write it? X bar, Y bar, Z. Similarly, what about 2? 2 means 0, 1, 0. Okay, how do you represent it? X bar, Y, Z bar. I am correct. So I want to perform sum. So in order to perform sum, what happen? We are going to using for OR gate. Okay, using for OR gate. So this is for as a OR gate. So final output is sum. Okay. So now successfully implemented sum. Same procedure you are going to apply for the carry. Same procedure. What happen? You are going to apply for the carry. So what are the output going to generate? 0, 1, 2, 3, 4, 5, 6, 7. Okay. So I am taking for 3 by 8 decoder. 3 is the input and 8 is the output. Okay. So what is our, so what are the parameters taken as input? X, Y, Z. X, Y, Z. Okay. Okay. And then look at that Boolean function. Okay. 3 is enabled, and then 5 is enabled, and 6 is enabled, and 7 is enabled. Okay. Finally, how the output will look like? Okay. Sum of product form. Okay. How do we perform sum? Make use of OR gate. Okay. So this is a way what happened. We are going to implement full adder circuit functionality using 3 by 8 decoder. So do you have any queries? Do you have any queries?
No, sir.
Okay, let I am going to check that. For example, I am going to check whether the circuit is working properly or not. So for example, I am taking 3 bit as an input, namely called okay, X, Y, Z. So all the bits values are equal to 1. Okay. If you do consider the truth table, if all the bits are 1 in the sense, what is the value of sum? What is the value of carry? So sum equal to 1 and carry equal to 1. Okay, I'm going to check that. 1, 1. And then Z 1. So what happens, sir? So 1, 1, 1, all the bits are 1 in the sense what happened? 7 is enabled. Okay, 7 is enabled. This is enabled. The rest of the places what happened? The disabled. Okay, so that is the meaning is 0, 0, 0. This is a 1. So what it going to do? 0 plus 0 plus 0 plus 0 plus 1. What is the value? Value is nothing but 1. Similarly, same procedure you follow for the carry. So x equal to 1, y equal to 1, z equal to 1. What happens, sir? The 7 alone enable, the rest of the places what happen? Disable. Okay. How it going to generate the output? 0 plus 0 plus 0 plus 1. That is nothing but 1. Okay. Successfully it will generate carry sum equal to 1 and carry equal to 1. Okay, you can take any one of the input combination, so it will produce a correct result. Okay, it's okay for you? Hello. Do you have any queries?
No, sir.
Okay. Okay, you will try it out yourself. So now I designing full ladder using 3 by 8 decoder. So now your task is nothing but you are going to implement half adder using 2 by 8 decoder. Sorry, 2 by 4 decoder. Okay, how do you do that? How do you do that? Okay. So now, so now what I'm going to do, the implementation of half adder using decoder. Okay, you are going to tell the answer. Okay. What is the first step? What is the first step? The first step is nothing but you want to form a truth table. So before forming the truth table, you should know that the operation of uh, the operation of half adder. Okay. So what it going to does, it take it as input as a 2 bit. Okay, and then it's going to produce a output. The output component is associated with the two variable. One is called as a sum, another one is called as a carry. Okay. So from this, what happen? You are going to form the truth table. Okay, you take it as you take it input as a 2 bit. Okay, so what are the two bits? Instead of xy, what happen? I take it as AB. Okay. So what is the answer? Anyone tell the answer? What is the output for what is the output of 0 0 combination? 0 1 1 0 1 1? Anyone tell the answer? What is the carry? What is the carry?
Zero.
Zero. What next? What about next? What about next one? What about next one? 0 plus 1, what? 1. What about carry? It does not generate any carry. Similarly, what happens? Sum. Sorry, second input combination. This is 1, this is 0. What about next one? 1 is nothing but 10. Okay, sum is 0 and carry is a 1. Okay, from based on that, what happen? Then you should designing your circuit. Okay, how do you do that? So first, I'm going to designing the circuit for sum. So what are the places output equal to 1? So these are the places output equal to 1. I'm going to take the respective input values. The input values 1 comma 2. So what about next one? You want to designing the Boolean function for carry. If you consider the carry here, this place alone, the output equal to 1. So you take the respective input combination. That is nothing but 3. Okay, so in order to implement that circuit, how many decodes are required? So only one single 2 by 4 decoder is enough. Why sir? Here 1 2 is there, here 3 is there. Okay, so how do you implement that? So this is the way I'm going to implement that. 2 by 4. Okay, what are the outputs? 0, 1, 2, 3. Okay, how do you do that? So what is the meaning is 1 plus 2. Okay, sum of product. Okay, so how do you do that? Using OR gate. Sorry, 1 2. Okay, 1 2. Okay, this is OR gate. This is nothing. Sum is 1 plus 2. What about carry equal to 3? 3 is nothing but AB. Okay, the sum otherwise we can written as like that. How do you write it? That what is the binary representation of one 0 1? So A bar B. So what about 2? A B bar. Okay, instead of that 1 plus 2, what about you can written as like that. A B bar. Okay, it's okay for you.
Yes, sir.
Okay, we're going to take it as a 2 bit. Okay. Next, I'm going to take one more example. The next one is um, they implement the following function. Implement the following function using decoder. Okay, they given three bit as input a comma b comma c, and then the given the equation is abc. Okay, that is a function they given. Okay, here you no need to form truth table because already they given the boolean function. Already given the boolean function. So what is the constraint of the Boolean function in the sense? It should be appear in the form of sum of product format. Should be appear in the form of sum of product format. What is the guidelines for sum of product format? So all the variables should be appear in the sum of product form. Okay. the Boolean function should be appear in the form of sum of product form. So what is the guidelines for sum of product form means all the variable should be present. Okay, all the variable should present. Okay, this is a three variable function. So obviously what happen? If we consider any component, all the three variables should be present. All the variables should be present. Okay, if we consider that equation, okay, for example, if we consider the Boolean function, it associated with the two component. One is this one, second one is this one. If we consider the first component, okay, so what are the variables are missing? B is missing and C is missing. Okay, you can follow any way. Okay, instead of okay A, the B is not there. So how we are going to introduce? Okay, like the way what happen, you are going to introduce a B and then C. Okay, you can do this way also. Otherwise, what happen? What happen? Here, sir, here B is not there, and then C is not there. X is not considered as don't care condition. Considered as a don't care condition. Considered as a don't care condition. Okay. Here, two don't care conditions are available. So, if we consider the first component, two don't care conditions are available. If two variables are available, means how many number of combination? 4, 0, 0, 0, 1, 1, 0, 1, 1. Okay, A. Similarly, here what happens, sir? Here only one variable is there. So one means two output combinations are available. That is called as a 0 and 1. Okay. So based on that, you should form the equation. So what is the equation? A B bar C bar plus A B bar C A B C bar ABC. And so this is nothing but 3 and 4, 5, 6, 7. So what about this one? This is nothing but A bar B C. This is nothing but A B C. What's the value? So okay, this is 1, 2, 4. This is 3. 3. This is a 7. Already is there. Okay. So final value is 3, 4, 5, 6, 7. Okay. Okay. So now you got all the output. Okay. What is the range of the output? The output range is appear from 0 to 8. So you needed 1 3 by 8 decoder. Okay, 1 3 by 8 decoder. So what are the inputs? A, B, C. Okay. 1, 2, 3, 4, 5, 6, 7. Okay, now we should draw the diagram. Okay, so 3, 4, 5, 6, and 7. Okay, so all the inputs are connected with one OR gate and it's going to produce output. Okay, so do you have any queries? So do you have any queries?
No, sir.
That's all about decoder. That's all about decoder. Next, I'm going to begin with encoder. Next, what I'm going to begin with the encoder. No. Next, I'm going to begin with the encoder. The encoder is one of the combination circuit. It is a combination circuit. It is one of the combination circuit. It takes it takes multiple input data, full data, and converts into a single binary code. Single binary code. Okay. First, I'm going to take the decoder. So, what is the structure of decoder? If you consider the decoder, it should be appear like that. What is the meaning is 2 by 4 decoder. What is the meaning is it's going to take input as a 2 bits, output as it should be appear in the form of 4 bits. Okay, what do you understand from this in the sense? If suppose xy is the input means, so what happen in go? So what are the outputs are possible? Okay, what are the output possible? X bar, y bar, x, y bar, sorry, x bar y, next x, y bar, x, y. Okay, if you consider the encoder, it is a just opposite to, it is a just opposite of decoder. So what is the meaning is, okay, it's going to take 4 bit as an input and it's going to produce output as a 2 bit. Okay, what is the meaning is, okay, for example, same thing. This is 00, this is 01, 10, 11. I am correct. Okay, it is okay. It is the opposite of decoder. Okay, so 4 is a number input, and then 2 is a number output. In generally people called as, okay, for example, generally people called as 2 power n into n. Okay, suppose the n value equal to 2. Suppose the n value equal to 2. What happens? 2 power 2 into 2. So what is the meaning is 4 into 2. Okay, so what is the output is, okay, it's going to produce output as a 2. Okay, either 0 or 1. Okay, so what previously I said, that can be represented in the generic format. Okay, okay, so 2 power n as a input and it's going to produce output as and bits. Okay, output as and bit as output and bit as an output. Okay, this is the input. The input is nothing but 2 power n. Okay, this is the general specification of input. Okay, do you have any queries? Do you have any queries?
No, sir.
Okay. Uh, Similarly, if you consider decoder, what happened? What are the different ways we can implement it using active high input and active low input? Similarly, what happened? It going to generate the two output. One is called as active low output. Another one is active high output. Same procedure we are going to follow again. Okay, what is the first one? The encoder with enable high enable high. Okay, how do you do that? Okay, so this is a representation of encoder. So what happen is going to take input as to program input as, this is the input. What is the output? Output as generated as a 4 bits. Okay, and bits as output. So here what happen? For example, in the integrated circuit, more than one decoders are available. At a time, I want to enable only one decoder. How do you do that? Make use of enabling. Okay, this is called as active high. Okay, active high input. Okay, already you know that the functionality of active high. What is the meaning of active high? If the e value equal to 1, what happen? Okay, what happen? It enable the circuit. It enable the circuit. Suppose the e equal to 0. No operation. If E equal to 0, what happened? No operation. Similarly, for active low output, so next what happened? I'm going to implement encoder with enable input high enable active low input. Active low input. How it should be appear? Same, but same thing. It's going to take 2 power n as an input and it's going to produce output as n. Okay, this is as the output. So n bit as output, n bit as output. This is the input. 2 power n as an input. Okay. So only one changes. So whenever we are going to providing the enable input, so along with that what happen? We are going to add bubbles. The bubbles otherwise called as an inverter. Inverter. Here what happened? Suppose the input the enable bit equal to 0 means what happened? Okay, to start enable the circuit, otherwise called as enable the circuit, enable the circuit. If the input equal to 1, there is no operation. If the input equal to 1, there is no operation. Okay, do you have any queries? Okay, do you have any queries?
No, sir.
Okay. So next I'm going to demonstrate. So what are the different type of, next I'm going to demonstrate. So what are the different type of encoders are available? Demonstrate. So what are the different type of encoders are available? So different types of encoder. Different types of encoder. The first I'm going to construct 4 by 2 encoder. So what do you understand from this? Okay, it's going to take input as a 4 bits and then it's going to produce the output as 2 bit. Okay, so for example, so I'm going to take input as D0, D1, D2, and then D4. Okay, this is a 0, this is a 1, this is a 2, this is a 3. Okay, well, what happened the output? It's going to produce output as a 2 bit, namely called 0, 1, 1. Okay, this is a 2 bit. Okay, so this is nothing but the specification of encoder. This is nothing but specification of the specification of 4 by 2 encoder. So what we have seen in the diagram that can be represented in the truth table. Okay, D0, D1, D2, D3. This is the input. What about output? The output is namely called AB. 0, 1, 2, 3. Okay, 0. Okay. So what is the meaning is? Okay. The first two, for example, 4 input combinations are available. What is the meaning is? You are going to provide input as 4 bit, 4 input combination. Suppose in the 4 input combination, suppose I am going to provide input 0 means 0 alone enable, the rest of the bits are disabled. Suppose I am going to give the input as 0 means, okay, this D not alone enable, the rest of the things are disabled. So what happened? The output is nothing but I am going to provide input as 0. So the output is nothing but 0. Suppose I'm going to provide input as a 1. What is the binary representation? Suppose 1 in the sense D1 alone enable, the rest of the components are disabled. Okay, what is the binary output? It's going to generate output as 1. Okay. Okay. Similarly, suppose I want to provide input as a 2. How do you do that? D2 alone enable, the rest of the places are disabled. Okay. So, sir, what is the output in the sense? You consider D2 parameter. What is the value is there in the suffix? There is the output. Okay. For example, if you consider the first case, okay, here only what happened? The input one, the rest of the places are out the zero. So what is the output? Zero. Okay. So what I'm trying to say that consider D. This D is suffix. What is the value is there? That is the output. Okay, here 0 is the 0 is output. Here 1 is the here 1 is output. Here 2 is the 2 is the output. Next. Okay, now I'm going to provide input as a 3. Okay, that's why D3 alone 1. The rest of the places the input equal to 0. So what is the output? The D suffix, what is the value is that? There is the output. What is the output? 3. Okay. Okay. So this is a truth table for okay, this is a truth table for uh, a 4 by 2 decoder. Okay. So now, what happened? You want to designing the circuit. How do you do that? Okay, you had the two output. Okay, one is called as A, another one is called as B. Okay, okay. You want to designing the circuit. How do you do that? First, you consider the A output. What are the places output equal to 1? Okay, the output here output equal to 1 and here output equal to 1. Okay, you take the respective representation D dash, D1 dash, D2 and D3 dash. Okay, so what about okay. Okay, so for here, look at that. Here only what happened? The input equal to 1, the rest of the places output 0. So what I'm going to do? So A equal to, directly I'm going to write D2 plus, if you consider this one, what happened? Here only what happened? D3 is 1, the rest of the places, the value equal to 0. That's why what happened? I'm going to take D3. So otherwise what happened? You can write it as in the form of sum of product format and then you want to simplify it. So that also what happened? It produces same result. Okay. Okay. Next, similarly, what happened? You take B. Okay. So what are the places output equal to 1? Here, here. You take the respective input comes D1 plus uh, D3. Okay. That's all. Now you successfully got the Boolean function. So now you try to draw the circuit diagram. How do you do that? Okay, 3 D0 D1. Okay, D2 and then D3. Okay, what is the first thing? D2 plus D3. D2 plus D3. Okay, you needed 1 hour circuit. What about next one? D3 plus D1. D3 plus D1. Please require 1 hour yet. Okay, and D1 plus D3 is called as a A, and D2 plus D3 is called as a. Okay, this is a circuit diagram for 4 by 2 encoder. So do you have any queries? Do you have any queries?
No, sir.
Okay. Okay, any absent is there? Okay, thank you so much. If you had any queries, to be stay on online, otherwise you can wind up the session.